Okay, in this formula, I want to establish this new derivative formula, the derivative of the natural log function. And we have this over here in highlighted yellow. The derivative of ln of x is 1 over x. And let's just see why this is true. Let's apply our old limit definition of the derivative. So applying the limit definition, the derivative of the natural log of x should be the limit as h approaches 0 of the natural log of x plus h minus the natural log of x all divided by h. And so let's use one of these natural log properties I have over here on the right. We have number 4. The difference of two natural logs is equal to the natural log of the quotient. So we could take the numerator. Actually, let's take this over h and move that out front. All right, so let's say this is the limit as h goes to 0. We'll bring that 1 over h out front, and we'll combine those two logs into 1. So that's the natural log of x plus h divided by x. Okay, so now let's do a couple of things. One, let's split this, the argument of the natural log. Let's split this fraction up into 2. So let's say that's the limit as h goes to 0. So we'll say natural log of 1 plus h over x. And we could apply property number 3 over here, and we could bring this 1 over h up top as an exponent. All right, so let's go ahead and do that. So we'll have the 1 over h up here. Now I'm going to do a slight algebraic, a little trick here, and let's multiply the 1 over h by x over x. And the motivation here is I'm thinking about the number e, and the natural log of e is equal to 1, and the definition, the limit definition of the number e is the limit as n goes to infinity of 1 plus 1 over n to the power of n. All right, so I'm trying to sort of take what I have over here on the left in blue and make it look like something in there. I'll make something in there look like the number e. Okay, so let's take that x over x and let's do something like this. We'll say the limit as h goes to 0, natural log of, well, we've got 1 plus h over x to the power x over h. So I'll use this x, and I'll put that with the h, and then let's leave that. And then the other x we'll put out here. So there's our x over x. The numerator x is on the inside, the denominator x is on the outside. Okay, so now let's reapply. So another arrow here, we'll reapply property 3, and we could bring this 1 over x out front. Same property, just in the reverse. Okay, so we have the limit as h goes to 0 of 1 over x times the natural log of 1 plus h over x to the power x over h. Now, if we're looking over here on the right at the definition of the number e, the denominator of this fraction has to be the same as the exponent. That's easy enough to do. The reciprocal of a fraction is the original fraction. So let's say, and well, also, the limit is as h goes to 0, so there's no h here. So this 1 over x is a constant. We could bring that out front. So let's say this is equal to the, 1 over x times the limit as h goes to 0 of the natural log of 1 plus, now let's take the reciprocal of the reciprocal, so 1, instead of h over x, we could say 1 over x over h. And that's to the power x over h. And so the exponent and the denominator are the same. And now see, this is, as you can see in the definition, this is as n goes to infinity, and in our limit we have as h goes to 0, but that's okay, because as h goes to 0, x over h, if the denominator is going to 0, this goes to infinity. So the h goes to 0 is equivalent to saying x over h goes to infinity. So when we apply the limit to the arguments of the natural logarithm, this is the definition of the number e. So this goes to e, and what we have finally is 1 over x times the natural log of e, which is 1 over x times 1, or 1 over x. And there is our proof that the derivative of the natural log function is 1 over x.